Hi, this is Ms. Gonzalez, and today I'm going to go over 11.6 on page 597 and 598. First, I will go over the guided practice, some of the directions of the independent practice, and then we'll see some of the directions of the problem solving in the back. First, let's look at the guided practice, and some of these guided practice questions are the same as the ones at the bottom. So pay close attention as I go over these. For number 1 and 2, use the number lines to write each fraction as a sum of unit fractions. Now notice it says sum, and sum means to add. In unit fractions, we went over last week, and that is when you have one part of the whole. So right now it's at 3/8, but they want to know, how did you get 3/8? Well, remember, we can do the problem in reverse. Normally we see the answer on this side, but we're going to put the answer here, and we're going to show how to get that answer. So to get 3/8, we are going to write it in unit fractions like this. 1/8 plus 1/8 plus 1/8. When added together, the top is 1 plus 1 plus 1, and that equals to the 3. And the denominator remains the same. So again, they asked us for the sum, and we wrote a sum right here. We wrote an addition problem. Down at the bottom, they already did the number line for us, and it's on 5/6. They want the sum of the unit fraction. So just like the top, we're going to go ahead and do the same thing to the bottom. And so I need 5 units. So 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. If you add them all together, the units on the top, 1 plus 1 plus 1 plus 1 plus 1 gives you 5, and the denominator remains the same. Let's look at number 3. It says in 3 and 4, use the number line. So we're going to use this number line to answer both 3 and 4. Number 3 says, which of the following is equal to 3/4? And 3/4 is right here. If we put a dot on that one right here, it'll look just like the ones that are here. And I do the leaps like this, 1, 2, 3. But it looks like they want the sum of the unit fraction. They want the one that equals to 3/4. So remember, you're going to count the top, and you're going to make sure that the denominator stayed the same. If I look carefully at the first choice, the denominator is not the same as the one right here. The second choice is 1/4. It is the same denominator. The only thing is that they wanted 3/4 as the answer. So this cannot be the answer. And finally, we get to the last choice. I need to find 3/4. And if I add up the numerator, 1 plus 1 plus 1, it does equal to 3. But I checked the denominator, and sure enough, it's the same as the denominator on my number line. So this is the answer. Circle the fraction that is equal to 1/4 plus 1/4. Well, they already wrote the problem for me right here, so I'm just going to go ahead and put an equal symbol and then add up the units. 1 plus 1, that is 2. And remember, the denominator stays exactly the same. So my answer is 2/4. So this is the answer for number 4. At the bottom of the page in our independent practice, we work on number 5 and 6 just like we worked on number 1 and 2 right up here. So you have to show the sum. It says, I need a sum, and it has to have unit fractions. So make sure you write a math problem for each of these, just like we did the ones on the top. So these two need exactly what you did on number 1 and 2. As we move down to the bottom, they are also looking for sums with unit fractions. They already wrote the answer, but they want to know, where did you get that answer from? I'm going to show you how to do number 7 quickly. That one's 4/6, but in order to get 4, I need 4 units, and the denominator must remain the same. So I'm going to have 1/6 plus 1/6 plus 1/6 plus 1/6. Now, if you don't have enough room right here, you can simply write it down at the bottom and write it neatly so that I could see your work when you turn it in. And then finally, when you get to number 11 and 12, you work on these just the same as you did question number 3. Question number 3, you had 3 choices, and you had to choose the one that matched the fraction here. Which one shows the sum of that fraction? And so this one says 2/3, so you have 3 choices. How are you going to get 2/3? And number 12 does the same thing. And that's how you do the independent practice. I'm going to go over some of the directions in the back of this assignment. On the first one, it says Zach wants to write 4, 6 as a sum. And here's that word sum again. Notice there is no sum in this problem. I see a number line, but I don't see a sum. It says, and it has to be in unit fractions, just like the front. He says that his unit fractions will be in fourths. Explain why he is incorrect. Okay, remember he says that it's going to be in fourth, but I want to know why he's incorrect. First of all, take a look at the denominator. The denominator says 6. Is it in fourth? Think about that to answer number 13. Answer it in a complete sentence here, and do not forget to show me the sum. So you have 2 jobs. First, in part A, find me the sum. So you can do it right here. And then in part B, write me a sentence telling me why he's incorrect. So for this one, you simply write a sentence telling me why he's wrong. Okay, you can use all this space to write your sentence neatly. When you get to number 14, now that's a STAR question. So they have seen these on the STAR test. It says, Christy wrote 6, 8 as the sum of the unit fractions. Which of the following did Christy write? Okay, so they're looking for which of these is the correct one. And remember, always look at that denominator. If I put it out here, nice and big, take a look at that denominator and then take a look at the unit fractions as they provide it for you. The next thing you do is you check the top number, and when added together, the units should give you 6. For instance, look at B. If I add these up together, it says 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. But when I add those together, that gives me an 8. I don't see an 8 up here, so B cannot be an answer, for instance. Could have been a distractor, but it's not the answer. Now, let's move along to number 15. Now, for number 15, you're going to use this chart right here. And it says here, use the table on the right. So for both of these problems, you need to make sure that you use this table to figure out your answer. And I want to read carefully. I want to read with you the question here. And you're going to see that there's some words that you've already studied this year. It says, James enjoys boating in the summer. How many more hours did James go boating during June and July than in May and August? Now, if I underline the question right here, which you should always do, I underline the question, and then I'm going to circle important information. Now, I see that there's no numbers here, but there is numbers on the table. So this is where I'm going to get the numbers that I need. But I'm noticing something, and I hope you noticed it too. It says more, and it says than. Now, we studied that all year, and that means that this problem is going to have some type of subtraction. But then I've noticed something. They want June and July together, and I see this word and we had studied this since the beginning. When they put them together like this, they want addition. And then I see the same thing right here. So what I'm going to have to do is first do the addition, and then when I find the 2 answers, I'm going to get the final answer. Now, this is going to be a 3-step problem, so prepare yourself to do a 3-step problem, maybe right here. Okay, and we said we were going to add first. So on this one, I'm going to add one of the problems, and then this one, I'm going to add the other problem. And again, you're going to be getting these numbers from this table right here. And then finally, I'm going to do the more than part. We have done these types of problems in class. We can't forget what we learned, so be very careful with number 15. Now, next one says, how many fewer hours did James go boating in May than in June? Draw a strip diagram to model and solve the problem. So this one wants 2 things. They want an answer for your math problem, and then they want you to draw strip diagrams. So don't forget the 2 parts that you have to do. Now, here's the question that they're asking. And again, there's no numbers here because they want you to get the numbers from this table. Now, I'm noticing that it says fewer. And we learned that ER words are comparing words. And comparing words means subtraction. Okay, so now I see that they want the number for May and they want the number for June. Okay, we're going to be getting those numbers. But if it is subtraction, then the strip diagram should have the information on the strip diagram correctly. For instance, of course, first, part A, you have to figure out the answer. And be careful because many of us do our strip diagram with part, whole. But that's for addition. Make sure that in this one that you first figure out the problem and then you're going to get the whole. And then you can get the 2 parts for subtraction. Okay, so first, do the algorithm. And it is subtraction. So if I see May, I'm going to go over here and get the number for May. But it also said June. So then I look carefully. You know what? The number for June is much bigger than May. So first I'm going to put the 77 right here. And then I'm going to subtract the 62. Then I'm going to get the answer right here. Then from there, I can go ahead and do part B. So you may go ahead and now draw a strip diagram to represent your number. Of course, the largest number being on top because it is subtraction. So find your 3 numbers and then put them carefully in your new strip diagram. At the bottom, it continues with a review of strip diagram. I'm going to go ahead and read this with you, and then we're going to talk about what kind of algorithm we should make. Becky handed out 12 t-shirts to 6 campers. If each camper got the same number of t-shirts, how many teachers did each camper get? And here's the question, and I'm noticing some things. It said the word each, and then for us, that means that could be multiplication. But then I see something that overpowers it. I see same number. So now what are you going to do? Whenever we saw same number while we were in class, we went ahead and used division because each can mean multiplication or it can mean division. But in this case, same number overpowers it and it becomes division. Okay, so I'm going to go ahead and write the problem. 12, because that's the larger number, that's the total. And then you have 6 campers. They want to know how many teachers each of the campers will get. Once you figure out that, you can write the answer inside the little question, by the question marks. And the last question says, Emma wants to write 4/8 as a sum. And here's that word sum again. And they already have the fraction here. And it has to be in unit fractions. It says, circle the choice that is equal to 4/8. So I have 2 choices. You have to circle the one that's correct. But then it has part 2. Draw a number line to justify your answer. So once you have done this, create a number line. And remember, all number lines start with 0 and end with 1. And then you cut it to 4/8. When you do that, you cut it in half. Right here, it's going to be really easy. Cut those in half and then cut those in half again and you will create 8. Now I wanted to remind you, whenever you're working on the problem solving section in the back, a lot of them have more than one step. So make sure that you complete all the steps in order to get your answers right. Now this is Ms. Gonzalez again, and thank you for listening to this lesson.